Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. You are given 3 large boxes and 5 small balls. All of the balls could be fit in one box, but instead the balls are put randomly in the boxes, with each ball having equal probability of falling into any of the 3 boxes. Let n be the number of boxes in which no balls are put. Find the variance of n. The possible values of this random variable are n equals 0, 1, and 2. We will calculate the probability of attaining each of those 3 values. We begin by calculating the probability at n is 2. Each of the 5 balls has 3 boxes to choose from to fall into, so the total number of possible outcomes is 3 to the 5th. There are 2 boxes with no balls if all balls fall into one box. Since there are 3 boxes that could be one with no balls, probability at n is equal to 2 is 3 divided by 3 to the 5th, so it's 1 over 81. Now let us consider the probability at n is 1. If one box is empty, the 5 balls are distributed among 2 boxes. If we pick a non-empty subset of the set of 5 balls, which is of size less than 5 itself, then that subset can go into one of the 2 boxes, and its complement goes into the other box. The number of ways to pick such a subset is 5 choose 1, plus 5 choose 2, plus 5 choose 3, plus 5 choose 4. But there are 3 ways to pick the empty box, so that the probability sought is 3 times the sum of those 4 numbers, divided by 3 to the 5th. That's 90 over 3 to the 5th, or 30 over 81, or 10 over 27. Finally, probability at n is 0 is 1 minus the 2 probabilities that we found, and that turns out to be 50 over 81. This gives the probability that n, this gives the expected value of n to be 0 times 50 over 81 plus 1 times 30 over 81 plus 2 times 1 over 81, so it's 32 over 81, and the second moment equal to 0 squared times 50 over 81 plus 1 squared times 30 over 81 plus 2 squared times 1 over 81, and that's 34 over 81. The variance of n is the second moment minus the square of the first moment, so it's 34 over 81 minus 32 over 81 squared, and that's 34 times 81 over 81 squared minus 30 squared over 81 squared. That turns out to be 1730 over 6561, approximately. This is incorrect, 0.2637, and that's answer B. Please remember this is copyrighted material. The problem was created by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.